the doorbell ring. Your counters are going to represent the cookies in this problem. So once you have 12 counters, please stop touching them. Once you've got 12 counters, stop touching them. All right, so we read our story, The Doorbell Rang. And in the beginning of that story, Mom made 12 cookies. That's why you've got 12 counters in front of you. Stop playing with that, please. At the beginning, how many kids were sharing the cookies? When we first read that story, how many kids were sharing the cookies? Kaden? 3? Nope. Was it 3 kids? Rylan, do you remember? 2. There's only 2 kids. So I want you to share your cookies with 2 kids. So make 2 piles to show one kid's pile and another kid's pile. Go ahead and start moving your counters. Remember, they share all the cookies. So all your counters should be separated. So on your desk, you probably have 2 groups, right? And you might have said, okay, 1 for you, 1 for you, 1 for you, 1 for you. How many cookies have I sorted so far? 4. Keegan? 4. I'm going to keep going because I have to sort 12 of them. 1 for you, 1 for you, 1 for you, 1 for you. They're still equal, right? I don't want to give a bunch to this guy because that's not fair. One for you, 1 for you, 1 for you, 1 for you. How many cookies have I shared now? Zach? 12. 12. How many did each kid get, though? Because each kid, I already asked you once to put that up. Each kid did not get 12. Huxley? 6. Each kid only got 6 cookies, right? All right, move your cookies back to make 12, because then we know in our story, our doorbell rang. And this time, we had 4 kids sharing. How many cookies did each kid get there? Go ahead and start moving your pieces. You need 4 kids. 4 groups. I'm going to make 4 groups because I've got my 4 kids. You should have 4 piles. Make sure you've got 4 piles. John, you got way too many piles.
Yeah, 4 piles.
Tegan, you don't have 4 piles. Separate them so you got 4 piles. All right, so we separated them into 4 groups. 1 for you, 1 for you, 1 for you, 1 for you. That's only 4. 1 for you, 1 for you, 1 for you, 1 for you. How many have I used now?
8.
1 for you, 1 for you, 1 for you, 1 for you. How many have I used now?
12.
How many did each kid get now?
3.
Sit up, John. Ready? Each kid got 3 cookies. Huh. Go ahead and push your cookies back to our big 12 because we know in our story the doorbell rang again. And now we have 6 kids sharing cookies. So you're going to need how many piles? 6. Go ahead and share out. Get your 6 piles and see how many cookies did each kid get. When you figure it out, raise your hand, please. All right, so I've got my 6 groups because I got 6 kids now. How many did each kid get? When you moved your cookies around, how many did each kid get? Carl?
2.
Each kid ended up getting 2 cookies. All right, because we know the story didn't end there. Push them back together, because again, the doorbell rang, and this time we had 12 kids sharing cookies. So how many tiles are you going to have, Mackenzie? 12. Make your 12 tiles. Because you got 12 kids. When you figure out how many each kid gets, raise your hand. Phelan, how many cookies did each kid get?
1.
1. If I've got 12 cookies, and I've got 12 kids, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's only enough cookies for the kids to get 1 each. Move your counters back to your big pile. Move your counters back to your big pile for right now. Move your counters back to your big pile, please. Move your counters back to your big pile. That direction is not tricky. Get your math notebook in front of you and open, please. This is your title on the next blank page. It said, what patterns are you noticing in our story? So go ahead and write that title down on the next blank page, please. What were some patterns that we noticed? As our story went along, what were we noticing? Macklin, what were you noticing in our story?
Each person gets 2, or now it's not 1. Each person gets 3.
Okay, so when we had more people, the number of cookies we shared was different. Love it. Let's write that down. When we had more people, the number of cookies each person got changed. At the beginning of the story, each person was getting 6 cookies, which was awesome. But then at the end of the story, each person was only getting 1 cookie because we changed the number of people. So when we had more people, the number of cookies each person got changed. Did you notice any other patterns? Sit up, Bryson. Evelyn?
Basically what we just wrote, but the more people we had, the numbers went down.
The numbers of what?
The numbers of cookies.
Yeah, so we noticed that, I'm going to do an up arrow for more people. Meant that we got less cookies each. So the more people we had, the less cookies I got once we shared the cookies. Every single time we still had 12 cookies, but once I shared it, I had a different amount that I was getting. Does that make sense? Okay, Heidi?
So besides from when the other neighbors came with all their cousins, you could just take 1 cookie from each person.
Yeah, as we were adding some people, we just kind of had to take one to give them to the next people that came in. Yeah. Rylan?
I noticed that
Sit up. Oh, you're up.
whenever people were coming in, the amount of people that were in the house,
Yep.
how many people were, how many kids were, it wasn't even number of how many kids there were after more and more kids. So it goes like, so when like 2, 4, 6, 12.
Yeah. Zach, what did you notice?
Kind of what like Heidi and Evelyn said, but every time like 2 people came, they would take away 2 people.
Yeah, it seemed like every time we got a lot of people, we all of a sudden couldn't share or didn't get as many once we shared cookies. Colby?
It's similar to what all you said, but it's like however much people or more come in after the 2 people eating, whereas how much less.
Say that one more time.
So like how much people come in after the 2 people then you get 7 cookies, and how much people come in is like the less cookies you get.
Yeah. When we share items equally, we're dividing. So that whole story is based in division. So think about that story. What do you think division is? That story was all division. So now that you know that, what is division? Jalen?
Cutting even numbers in half.
Not even numbers. Our story just happened to have even numbers. But I think what you mean to say are equal numbers. Each person gets an equal amount. Ariana? Okay. Kaden?
You know how it's a more powerful version of addition is multiplication?
Yep.
I feel like it's a more powerful version of
Kaden said, you know how multiplication is the more powerful version of addition? Right, we know that. So he's saying, I think division is the more powerful version of subtraction. What do you think about that? Kaden, can you explain that thought to me?
But I'm just understand what that means. So, like in groups of subtracting.
I think you're completely right. Completely right. We've got some subtraction happening. We're kind of getting less things. We're giving things away. That feels very subtraction-y. Rylan?
Just like what Hayden said.
Yep.
Like the division, like
Colby's not spinning.
where like you have it's multiplication that, but instead of times, it's like the sign. It looks like a minus sign, but with a dot on the top and a dot on the bottom.
Yeah.
And it like makes you take away how many are in a so it makes you take away either
Yep.
It makes you take away root, but subtraction, you just take away that number. You don't take
Oh, so I'm gonna repeat what Rylan just said, just so everyone understands what he's saying. He's kind of explaining Caden's idea of it being more powerful subtraction. When I subtract, I can really just count by ones, right? I can just count backwards. But when I'm dividing, I'm subtracting groups. Kind of like multiplying is adding groups. It's like backwards skip counting, right? Yeah, nice. This is going to be our next title. Turn to the next blank page, even if you have room, because we're going to have erase that circle and use that page. That's okay. We're going to talk about it right now. Yep, we're going to talk about it right now. So this is your title on the next blank page. We're going to do a lot of writing, thinking, sharing. So make sure it's on the next blank page. Evelyn?
Can I tell you what you have to do with writing
So? Because it's the same thing. Zach?
The last question you asked, I think it was kind of like take away double.
Yeah, kind of.
Instead of taking
All right, so first I want to talk about symbols. Division has two symbols. The first symbol is the one that we're all very familiar with. It has a horizontal bar with a dot on top and a dot on bottom. This is your normal division symbol. I'm writing, you're writing. However, my computer and your computer cannot make that symbol. That's not an option on your keyboard. So there's another symbol that we use that you'll see me use when I type out problems for you, because I can't make that symbol on my computer. It's just a slash. So you're going to see those two symbols, and they both mean division. They both mean division. Heidi?
I realized something with the first one.
Yes.
It's just the subtraction sign and one of the multiplication sign.
Yeah, it's kind of like our multiplication sign, which we learned about, is like the higher multiplication when they use dots instead of x, because we know x could be a number. So we've kind of got minus and our groups in there. That's pretty tricky. Mathematicians, man, they're smart.
Why is there one on the keyboard that's like the opposite way?
They both mean the same thing. They just go different directions, but they both mean the same thing. Right?
The regular division sign, kind of look like, it looks like so there's the two dots, it looks like the two dots that are on your computer, where it has one and two dots and one, but the two dots have a minus sign,
Yeah. So when we're dividing, the language that I want you to think about is we are sharing equal groups. This piece right here, the equal groups piece, should be familiar because we made a lot of equal groups. John, I'm writing, you're writing. When we were multiplying. Colby, I'm writing, you're writing. So very similar in power, we are talking about groups of numbers. Kind of like with multiplication, we were talking about groups of numbers. Similar to subtraction, there are two ways to read a division problem. So we're going to do some translating. Okay? Go ahead and write the equation. 12 divided by 4. Actually, let's do 6 because that was our, or 2 because that was our first part in our problem is worth 6. I recommend, if you're writing, to use the normal division symbol and only use the slash when you have to type. Because it makes it easier to make sure everyone knows we're dividing. So we're going to put this in our story. What was the 12? 12 what? What was the unit that 12 was in our story? The doorbell rang. Tegan? The cookies. So we've got 12 cookies. I'm writing, you're writing, John. Stay with me. What's up with me?
You know the calculator on computers?
Yep.
When I tried to use that at home, sometimes I got the weirdest answers with actually some of the symbols in them.
Okay. What happened? We had 12 cookies and then what? Bryson, then what?
And then there was 12 people.
So at the end of the story, but at the beginning, what was happening?
Two kids were sharing and they got 6 cookies.
Okay, so we've got 2 kids. So 12 cookies put into 2 groups. So our division symbol, this symbol right here, means to put into groups. The number of groups is the next number. So in our story, we had 12 cookies put into 2 groups because we had 2 kids. John?
So it's like multiplication,
It's very similar, yeah.
but instead of adding, subtracting.
Yeah. We know what equal sign means. What does equal sign mean? Evelyn? Has. I'm writing, you're writing. Okay, hang on one second.
Same value.
Yep. Now this is where it gets tricky. Because it's not just 6 cookies. It's not 6 cookies. It's 12 cookies. So what does that 6 mean? We didn't get rid of cookies. There's still 12 of them. So what does that 6 mean? Think about the unit. What does that 6 mean, Rylan?
That 6 means that the group of 6 in each group,
Mm-hmm.
12 divided by 2 groups.
Yep, 12 cookies put into 2 groups has the same value as... No, I can't say 6. I need some extra words in there. Heidi, you think you got it?
What was the question again?
What does that 6 mean?
The 6 means like the groups. No, the 6 means how many like cookies are in those 2 groups.
Yeah, how many each kid got.
That's what.
That 6 means how many each kid got in this part of the story. So we had 12 cookies put into 2 groups, has the same value as each. Each is the important part. Each group or kid having 6 cookies. We had 12 cookies. We shared them with 2 kids, put them into 2 groups. And that's worth the same as every kid getting 6 cookies. Hang on one second. I know. I just want to give everybody a chance to write it down. But okay, we know addition, subtraction are kind of here. They're like the beginning levels. And then we got more powerful. We got multiplication. Now we've got division. She wants to know, out of these 2, which is more powerful, multiplication or division? And I told her, we're going to find out. We're going to think about it. We're not there yet. Carl, you had a question?
on our on our laptop, why is the normal division the division signs not on our computer?
I don't know. I don't know. I don't know. Ariana? I know where you're going. Hang on to that thought. All right. I told you there's another way to think about division, right? In our story, we just put things in groups. So far, so good. However, sometimes I might say, okay, we've got 20 kids. Whoops, that's not a kids. You do not need to write this now. And each kid all right, so scratch the original problem. I got 27 cars. So cars. You do not need to write this. But I want to put 3 cars on each shelf. So far, so good. How many shelves? Well, earlier we said, okay, we've got our total things, 12 cookies, and I put them into groups. But in this problem, I don't know the number of shelves. I don't know the number of groups. This part you are going to write in red. I had 27 toy cars. Yes, what I'm writing in red, please write this down. Yes, what I'm writing in red, you need to write down. The part that is written in my red pen. You can figure it out. You can figure it out. 27 toy cars. I am dividing. But it didn't tell me my groups. So I could say mystery box. Or I could read it as 27 toy cars with each group getting 3 cars. Those are how many go in each group, or shelf. You put shelf instead of group. Shelves and groups are going to be synonyms here. I've got 27 cars. Each shelf gets 3 of them. Is worth, oops, I'm not going to write equals down there. Nine groups. So you'll notice that I have almost the exact same words. I just flip-flop them. I have 9 groups, and I have the each part. When I briefly, I'm just going to turn it for a second. When I look back here, hey, look, I have groups, and I have each. I just put them in a slightly different order.
Why did you think you're cheap?
Personally, I think thinking about it this way is a little easier for my brain, but you can choose. You choose. Okay, then. Go for it.
So if you find uneven number like 5,
Uh-huh.
would you have to go with a group? Like 25?
Kind of. Now, an uneven number doesn't mean you can't divide. right? I divided all odd numbers just now, right? The word you're looking for is not even. Equal. That's the word you're looking for. As long as I can make equal groups, it doesn't matter if it's even or odd, if everyone gets the same amount.
Yeah. Say if you have 7, and you try to divide it by 3, then you do 3.5 for each person. I mean, try to divide it by 2, 3.5 for each person.
Yeah. Once, and that's going to be more of a 4th grade skill when you start looking at that. What you're talking about is remainders, is what those are called. But you're thinking about it the right way. And we'll talk about that a little bit in 3rd grade, because if Carl and I are sharing one cookie, am I going to get the whole cookie?
No.
Is Carl going to get the whole cookie?
No.
We're going to throw the cookie away because it's just not going to work?
No.
No. What are we going to do? What would make sense if Carl and I have to share just one cookie? Carl?
You can break it in half.
Yeah, we would break it in half. Half is not a whole, it's half of a cookie. But that could be what we do. Now, what gets tricky is some things it doesn't make sense to cut in half. What if Carl and I had to share a laptop? Would it make sense for us to cut a laptop in half? No. So that's where it starts to get trickier up in 4th and 5th grade. That's what they're talking about when we're talking about dividing. But yes, you're on the right track. You would just keep cutting it down until everyone got an equal portion. There's one more thing we need to write down. Turn to the next page. All right, we learned one division strategy today. You're going to need this for your homework. This is your title. We learned one division strategy today. I will tell you this is one of my favorite division strategies. It's one of my go-tos. I use it a lot. It's a strategy you saw me use on the board. And it's a strategy I saw several of you using. You just might not have known it was called this. I call it.
Yeah, I didn't even know one.
Dealing out.
Wow.
So at my house, especially when I was a kid, I used to play board games with my family, or card games. And when you play a game that has cards involved, usually someone is a dealer. They have to be the person that gives everybody the cards. So if I'm playing with Tegan, Matthew, Bryson, I might say, okay, one for you, one for you, one for you, one for me. And then I go around again. One for you, one for you, one for you, one for me. And that way I make sure everyone got a fair number of cards before we play. Raise your hand if you've ever seen a dealer like that. Maybe you played it, or someone in your family has been a dealer. If you've ever played the game Uno, that's a really good game where you can see someone deal out. So, in our original equation, we're going to write that down again. We had 12 put into 2 groups is worth 6 in each group. I'm writing, you're writing, John. The dealing out method says, okay, I'm going to draw my groups. That's my 2.
Draw the groups.
Yep. And then I keep dealing out all 12 cookies until there's no more. So I'll say, okay, 1 for you, 1 for you. How many cookies have I dealt out? 2. Is that all 12? No, I gotta keep going. 1 for you, 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 1 for you. How many cookies have I dealt out now? Zach? 8. Is that 12? Gotta keep going. 1 for you, 1 for you, 1 for you, 1 for you. Are they equal.
Yes.
I'm not saying even, I'm saying equal. Did each person get the same amount?
Yes.
Yes. How much did each person get?
6.
6. That's my dealing out strategy.
Dude, I don't even know. I keep forgetting what it does all